Welcome back to the Python Praxis. This is the final part of our lesson on loops, and it's where things get truly powerful. So far, you've seen how for and while loops work, and how we can guide them with break, continue, and else. Now it's time to level up and explore two advanced patterns: nested loops and infinite loops. Nested loops allow us to handle multiple dimensions like pairs of coordinates or matching elements across lists. They actually let us work with multiple layers of repetition, which is perfect for grids, tables, and matching pairs of data. Then, we will explore infinite loops that, although they sound dangerous, they are actually at the core of many real-world applications, from video games to servers and robots. By the end of this video, you'll have a deep understanding of how loops work in every possible scenario. In Python, loops can contain other loops inside them. This is called a nested loop. You can use this structure when you want to repeat a set of actions for each item of another set. The basic idea in the nested loops is this: if you place one loop inside another, the inner loop runs completely for every single step of the outer loop. In example 1, two loops, one nested inside the other, can work together to generate and print coordinate pairs. In the code now, we have an outer for loop for x coordinate that goes through a range of numbers from 0 inclusive to 3 exclusive. Then we have an inner for loop for y coordinate that goes through a range from 0 inclusive to 2 exclusive. Inside the inner for loop, we have a print statement that prints the pair of coordinates. The result is all pairs from 0.0 to 2.1. Similarly, in example 2, we use two nested loops for letter pairing from two words. The code in this example starts with two string variables that we assign the two words, and then follow the two nested loops in the same philosophy as in the first example. Nested loops are powerful for working with grids, matrices, or combinations. Let's wrap up with an interesting exercise: the alien guest list filter. Imagine you have a guest list for a spaceship. Some are VIPs, some are intruders. Create a program that filters out unwanted alien guests and counts how many VIPs are on board. If at least two VIPs are found, show a cool pattern; otherwise, display a rejection message. Now, we will go through the code line by line. In line 1, we begin by defining a list of VIPs. The name of this list is VIP list and contains Zorg, Blip, and Mira. This means that only Zorg, Blip, and Mira are recognized as very important passengers. In line 2, we define a list of guests trying to board. This list is called guests and contains Zorg, Blip, Krax, Unknown, Mira, and Intruder. Some are real VIPs, like Zorg and Mira, but others like Krax, Unknown, and Intruder are suspicious. In the next line, we set up a counter, called VIPCount, to keep track of how many VIPs we actually find. We assign to VIPCount counter the value of 0 to initialize it. Next up, we start a for loop for guest in guests. This loop is going through each name in the guest list, one by one. In this loop, we add three conditionals in the following order. The first condition is if guest is equal to intruder. This is the first security check if the guest is literally named intruder. That's an immediate red flag. If we find an intruder, we sound the alarm by printing the message alert intruder detected, abort mission, and stop everything. The break command ends the entire loop right here. The second condition is if guest is equal to unknown. If the guest is marked unknown, we don't panic, but we also don't process them further. Here, the continue statement tells Python, skip this guest and move on to the next one. Finally, the third condition is if guest in VP list. This conditional checks whether the guest is found in our VIP list. And if yes, we increase the count by 1. That's one more confirmed VIP on board. Now here's something interesting. After this last check, we put the else statement of the for loop. Yes, you heard well. This else belongs to the for loop and not in any of the if statements. It only runs if the loop finishes normally without hitting a break. Inside the else block of code, we have an if-else statement. If VIP count is greater than or equal to 2. Here, we check how many VIPs we found. If there are at least 2, the mission is approved. The system welcomes them onto the spaceship by printing a message, "Welcome aboard." After the welcome message, we have another for loop. We add a little visual flair here. This loop prints a growing pattern of symbols, almost like a celebration banner. In the last two lines we have the else statement that will be executed, only in case the last if condition is false, which means that the VIP count is less than 2. This else block of code has only a print statement. It prints the message, "Not enough VIPs. Entry denied." So if fewer than 2 VIPs were found, the system denies entry. This small program beautifully demonstrates several powerful Python concepts: lists for storing known values, for loops to process items one by one, if checks for special conditions, the use of break and continue to control the loop, and finally, the unusual but powerful for-else construct. It's not just about code here, it's like running your own security system with Python. Now we will see something different. In some applications, we need to use loops that do not end. These are called infinite loops. An infinite loop is a loop that never ends on its own. It keeps running again and again forever, unless something from the outside or inside the loop forces it to stop. That's why we call it infinite. In Python, both while loops and for loops can become infinite, depending on how they're written. Where do we use infinite loops? Infinite loops are actually very common in real systems. In video games, the main game engine often runs inside an infinite loop, constantly updating graphics, sound, and controls. In servers and networking, infinite loops keep programs waiting for requests, like when a web server listens for new visitors. In real-time systems like robots, sensors, or Internet of Things devices, infinite loops are used to constantly monitor inputs and react instantly. When using infinite loops in your code, always keep in mind that infinite loops are a very powerful tool in programming, but also a little bit dangerous if not handled carefully. Infinite loops are not mistakes by default, they are often the heartbeat of a program that needs to stay alive. A while loop becomes infinite when its condition always evaluates to true. This is the most common way to create an intentional infinite loop, often used in servers, background processes, and games, where the program needs to keep running until an external event tells it to stop. The syntax is straightforward. In the loop header we write while true, followed by a colon, and in the next lines, always properly indented, we add the code block of this loop. Here, the condition is literally true. Since true never changes, the loop will never exit. This is the classic way to build infinite loops, and it is very common. In below example, Python will print the same message indefinitely. On the other hand, a for loop usually runs through a fixed sequence. To make it infinite, we use special constructs like itertools cycle or itertools count that provide an endless sequence. These methods are included in itertools module in Python standard library. Infinite for loops are less common, but useful when working with endless sequences or cycles. To be able to construct infinite for loops, we must first use the import command to import in our program the itertools module that is included in standard Python library so that we can use its methods in our code. The syntax is like this: for number in itertools.count:, and in the next lines follows properly indented the code block for this loop. In below example, Python starting from 0 will keep printing numbers forever. And that brings us to the end of our journey with loops. From simple for loops, to flexible while loops, to nested loops and infinite ones, you now have the full picture. These tools let you write programs that think and act in cycles, repeat tasks, and handle complexity step by step, just like the world around us. As you continue practicing, you'll see loops everywhere, in data analysis, in AI, in automation, and in almost every system that requires repetition. In the next lesson, we'll push forward into new Python territory and expand your toolkit even further. Until then, keep practicing, keep experimenting, and keep looping.